All right. So good evening, everyone. And thank you very much for joining. Today we'll be looking into the hot topic of incident response, and particularly incident response within AWS, and how you can contain your EC2 instances during an incident response. Right. So a bit about myself. My name is Lahiru Hewawasam. I am currently working at RCR Digital Labs as the lead for global cybersecurity operations. I am an AWS community builder in the security and identity category. I am a zero trust advocate and a technical writer. So today we'll be looking into what incident response is, the AWS shared responsibility model, the incident response lifecycle, how you can contain your EC2 instance during an incident response. We'll be jumping into a quick demonstration where I will show how you can isolate your EC2 instance, right? And also we'll be ending up or wrapping up with a quiz. Now, keep in mind that the winner of this quiz will get the chance to or we'll get $50 worth AWS credit. So please do participate and try to answer all the questions there. Now, let's begin. So, what is incident response? Now, incident response is basically the steps that you take in order to prepare, detect, contain, and recover from a data breach. So when I say a data breach, it can come in various shapes and sizes. So this can come in a very small scale or a large scale that we've seen over the last couple of major incidents that happened with large vendors and companies. So it's very important to know what your data incident response is to act accordingly. So to do this, we would need an incident response plan. So incident response plan basically documents the organization's procedures, steps, and responsibilities amongst its employees and stakeholders so that they are ready to act when an incident happens. Now, you must be wondering why we're talking about incident response when we're moving to the cloud, right? Because we've had an idea of, when we're moving to AWS, AWS will take care of all our resources, all the security and all that, but it's not completely true. So I have shared the shared responsibility model of AWS when you're looking at infrastructure as a cloud or infrastructure as a service. Right? So in this instance, you can see that AWS has segregated the responsibilities amongst AWS and the customer itself. So if you look at what AWS basically covers, it covers the underlying availability zones, regions, edge locations, compute, storage, database, and networking for its infrastructure. However, once you spin up an EC2 instance, the operating system security, the network security, firewall configurations, all that becomes the customer's responsibility. Not only the security aspect, however, considering about the identity and access management, that also becomes the customer's responsibility. And of course, at the end of the day, the customer's data is also the customer's responsibility. And the customer, at the end of the day, must protect all these assets that they spin up on the cloud. So this is where we need to pay attention to the incident response and the incident response lifecycle. So within the incident response lifecycle, we have the first stage, which is prepare. From there, we move on to detect. So once we prepare what we need to do on an incident, right? When an incident happens, we can move into the detection technologies. Right? So once you detect an incident or an event, next, what you're supposed to do is you're supposed to analyze the incident. Afterwards, after confirming that an entity has been compromised, you contain it. After containment, you move on to eradication of that specific threat, and you recover your business operations. So this is basically the incident response life cycle, and this keeps on revolving. And all organizations must get themselves familiarized so that they know what to do in an incident. Right? So we'll first look at the first, the first stage, which is the prepare stage. In the prepare stage of the incident response life cycle, it's important to define what your roles are as a security team, as your IT team, and all the other respective stakeholders. Right? It's important to define your response playbooks, and also it's important to place necessary technical controls. So all this done in the preparation stage will give you adequate time and technology to detect threats. So detection is done mainly using EDR solutions or XDR solutions. This can be third party that you integrate with the cloud, or one of the most familiar and famous or popular ways is by integrating it to an SIEM. So you need to integrate all the cloud logs and events to an SIEM. You do all the correlations, and then you generate alerts and act accordingly. However, AWS also provides native solutions so that you don't really need to have all these third-party tools. You can possibly perform most of the important actions using these solutions. So two such solutions are Amazon Guard Duty and Amazon Inspector. So these will not be looked at in depth. However, these are dedicated tools provided by AWS to make life easier for cloud or AWS users. Next, we have containment. So this will be the main focus of our session today. It basically talks about limiting the reachability of any resource, be it internal to the networks or external, so that it may not cause any more harm to other entities. We also talk about isolating. So basically, isolation is the same concept where you restrict access to all other networks. And also, it's important to restrict access to the infected instance, or in this case, EC2 instance, so that no one else can gain access to an already infected resource. Now, let's look at how we can contain an EC2 instance. So there are 4 key ways or approaches that we can do this. Starting from the bottom, we have our security groups. So security groups are very targeted in the sense, right? So you can use security groups for targeted isolations. You have NACLs or network ACLs that will restrict access on the subnet level. Then you have route tables that will restrict access on the external or egress communication. And you have internet gateways. So that's on the top level. So let's look at each one of them and see how we can use them to isolate our EC2 instance. First, we'll look at the security group. So when I say isolation of an EC2 instance, you might probably go and say, let's do it with the security group because that's the most easiest way. Now, the beauty of a security group is that its default state is an implicit deny, and the users must define what traffic they need to allow by adding rules. So it's important to remember that security groups are stateful, and if you have more than one security group added to an EC2 instance, basically AWS will grant access to the most permissive security group. So even though you have a security group that denies traffic, it will not basically deny traffic if you have another security group that basically allows traffic. So that's very important to keep in mind when you're dealing with an incident or incident response. Also, it's important to keep in mind that you cannot restrict access to an EC2 instance just by adding a security group. However, if you want to restrict access, you will need to remove all security groups or all the rules in a security group to isolate the EC2 instance. So when we're talking about security groups, we need to basically talk about two different things. We need to talk about tracked versus untracked connections. What these two are will determine how you isolate your EC2 instance. Untracked connections are basically traffic that has a source or a destination from a 0.0.0.0/0 address. So basically this translates to any. So this the term 0.0.0.0/0 is translating to any. So that's very important to keep in mind. On the other hand, tracked connections have a specific IP address or subnet that it's accepting or sending traffic to. So in this instance, we have 43.101.52.202. That's the IP address that we are talking about. So the security group will allow traffic from this particular IP address and nothing else. So why do we need to talk about these two? It's because with untracked connections, whenever you do a small change to the security group, be it changing a rule, removing a rule, updating a rule, or even deleting the security group, the traffic flow is immediately affected. However, with tracked connections, the traffic flow is not immediately restricted. Therefore, an attacker that has an existing connection onto your EC2 instance might still use that connection even after you think that you've isolated your EC2 instance. So basically, you might think that you've isolated your instance using the security groups. However, the attacker might still have that existing backdoor that they've created. So how do we actually work around this tracked connection issue? How do you do that is basically creating a dedicated isolation group, right? Creating a single 0.0.0.0/0 for all inbound and outbound rules, right? So basically, that's two rules from inbound and outbound from 0.0.0.0/0. Right? What you do next is remove all the existing security groups that are attached to this instance, associate this new security group that we have created, and then you delete the inbound and outbound rules that you just created. Right? So what this basically does is that it converts all the tracked connections to untracked connections, thus immediately terminating any connection that was associated with the EC2 instance. Now, you don't really need to have, or you don't need to really do these steps while you're performing incident response, because that's going to be a very tedious task. However, you can plan ahead with your security groups, right? So how you would do this is you can create a step 1 security group or an isolation 1 security group, right? With these two inbound and outbound rules, basically protocol type any, port any, and source IP from 0.0.0.0/0. Same with the outbound. Next, you create a step 2 or isolation step 2 security group with protocol, basically without any rules, right? So after you've created these two security groups, you can move into the actual incident response. Now, during an incident response, what you do is first you remove all existing security groups or rules within security group. Okay. Next, you add the step 1 security group to the EC2 instance. You remove the step 1 EC2 instance, remove the step 1 security group from the EC2 instance. Right? Then you associate the step 2 security group to that same instance. So what that basically did was it converted all the tracked connections, like what we did here, to untracked connections. And then from there, it effectively terminated all the connections. So that's how you plan ahead with security groups. Next, we can move into isolating your EC2 instances using NACLs, right? So, or network ACLs. It's important to remember that ACLs explicitly allow, or network ACLs explicitly allow or denies access to a subnet based on the rules that you create. So it's not an instance, however, it's a subnet. So it's also important to remember that network ACLs are stateless. So when you have a stateless connection, the network ACL will not account for the response that is coming through the network, or the response that is made, right? So you have to add the necessary rules to account for that. Okay. And like I said, you need to pay attention when you're using network ACLs to isolate instances, because it might inadvertently cut off access to an entire subnet. Right? Like I said, advantages of using network ACLs in isolation is that you don't have a multiple-stepped process. You inbound and outbound rules will deny all traffic, so you don't need to go ahead with the step 1 security group, step 2 security group, right? None of that. You can just add the rules and be done with it. However, this is not targeted and will actually cut off access to the entire subnet. If you want to actually contain your EC2 instances using network ACLs, what you need to do is basically, there are 2 ways of going about it, right? If you have a existing network ACL, you can add the deny rules to the top of the network ACL, right? However, if the network ACL is already full, you might need to delete some rules to make more space. The next step is to actually create a new network ACL and add all the deny rules to the top, and then associate this network ACL to the VPC that hosts the EC2 instance that you want to isolate. So remember that this is not attached to the EC2 instance, it's attached to the VPC instead. Next, we can move on to the isolation of an EC2 instance using the route table. So it's important to remember that one VPC can have only one route table. Also, if you do not create a route table, a default route table will be created at the time of creating the VPC, right? So route tables are a great way of restricting access to all external networks, right? Basically isolating the instance where, like, from internet gateways, direct connections, and also VPN connections. How you do this is by creating a custom route table without any rules and associate that to the VPC, or you can clear all the routes on the route table, right? That's also an option. However, it's important to understand that even though you restrict an EC2 instance using, or isolate an EC2 instance using the route table, the EC2 instance will still be able to communicate within the subnet. So it can still do harm to the rest of the EC2 instances within the subnet itself. So moving on, we have containing your EC2 instances using the internet gateway. So this is at the top level, and this basically cuts off all internet access. However, you cannot remove the internet gateway if there are EC2 dependencies within the VPC, right? So basically what these dependencies about, how to get around these dependencies, is to actually shut down the EC2 instance. Now, during an incident response, we don't shut down the EC2 instance. However, what we do is we actually keep it alive so that we can perform forensics analysis. That's very important. So in order to achieve the same effectiveness with an internet gateway, you can actually take off all the route table rules or routes that are associated with the internet gateway. So that effectively cuts off all the internet access to the VPC, right? Now, let's jump into a quick demo where I will show how we can actually isolate an EC2 instance. However, before that, I would like to show a sample or like a basic EC2 containment playbook. So you can use this to isolate your EC2 instances, right? So what you first do is detach your EC2 instance from an auto-scaling group, if it's associated with one. Create a new security group that denies both inbound and outbound traffic. This is your isolation security group. Remove any existing security groups and associate with this new security group, right? Remove any IAM roles that are associated with the instance. Create a snapshot of the root volume. This will be used for forensic analysis in the analysis stage or forensic stage, and also create an Amazon machine image that will also be used for forensics analysis. Now, during all these steps, keep in mind that tagging all your entities are important. Basically is important, right? Because then you will know not to use the same entities or resources for any other business operations, right? So you don't want to basically isolate the incidents using a security group and then join or basically use the same security group for your business operation. That'll be very bad, right? So let me just exit out of the slideshow and open my console, right? So here we have an EC2 instance running. So let's just assume that this is compromised at the moment, right? So what we're going to do first is to tag and detach the EC2 instance from its auto-scaling group. So how we're going to do that is basically going to go to auto-scaling groups. I'm going to click on the group and then go to instance management. So you can see that this is actually attached to this. This EC2 instance is attached to this auto-scaling group. So click on it and click on detach. Yep. So that is successfully detached, right? Step 2 is to create a new security group without any rules. So for that, you can head over to network security on the EC2 service and then click on security groups. So you should be able to create a new security group, and let's call it isolation. Okay. Isolation demo. Okay. So you can see that the default security group has an outbound rule. So for this purpose, we can delete that. And again, like I said, we can tag these because it's very important. Go and tag these as long as long as we know what we're doing. So it's very important. So we create the security group. Oh, it's fine. This as well. Right. So once this is created, we can remove any security group and associate with this new tool that we created. So let's do that now. So in order, how we can do that is to actually click on the instance, go to actions, go to security, change security group. So as you can see, there is a security group associated with it at the moment. So you remove that and you create associate the security group that we just created, and then we can click save. What that will basically do is cut off all access. So if you have any tracked connections, it's important to check if you had any tracked connections before you do this. However, in this example, I have not created any tracked connections. So if you go head on to security, you will see that there are no rules associated with it now. Okay. Next, we need to remove any IAM rules. That's very important so that the instance cannot talk to any other AWS services. So again, click on the instance, go to actions, security, modify IAM role, right? From here, you can see that an IAM role is defined or like associated with it in the EC2 instance. What you do is basically go and click on no IAM role. Click on update IAM role. So you might need to put in this and yep. So just to be on the safe side, let's double check. And now, as you can see, there are no IAM roles associated with this EC2 instance. Next, for forensics analysis purposes, we are going to create a snapshot. So in order to do that, you head over to snapshots under Elastic Block Store. You create a snapshot. In this example, what we're going to do is we're going to create an instance snapshot. So we're going to create, click our EC2 instance. We're going to say infected EC2. Okay. You don't want to exclude any of these, volumes, right? Instead, what you're going to do is you're going to do set, right? So make sure that the key and the value are the same across all your, entities or resources that you use for this isolation, right? And then you click on create snapshot. So this will take a little bit of time, so we can step on to the next step, which is creating an Amazon machine image. So for that, we can go to AMI, right? Oh, sorry. We have to go to instances, click on actions. From there, you go to image and templates and create an image. So you can create an image using this method. So for this, you can give it a name. So you can say EC2. So from this, you don't want to exclude anything. Again, tag as you go. So you can give the state as isolated and then create an image of the same EC2 instance. So now we have technically cut off access to our EC2 instance, or basically isolated our EC2 instance. And then we've taken the necessary snapshots for our incident response team to perform their incident response. So that actually wraps up our presentation and demo. So I hope that was very clear. I think I rushed through the demo. However, if there's any other questions, or if you'd like for me to run through the demo again, or for me to explain a little bit more, I would be happy to do that as well. So once again, thank you very much for joining, and please hang around for the quiz. And I would like to answer some questions if there are any.
Hi, Lahiru. Prabodhu here.
Hi, Prabodhu.
Hi. Thanks for the informative session. I have a question regarding this isolating EC2 instance.
Mm-hmm.
For example, let's say you have a lot of EC2 instances that you need to cut off all the connections, but it's very tedious tasks to do one by one, right? So you obviously have to do some automation over that.
Definitely.
Is there any AWS services that supports this kind of automation?
Yes. So you have AWS playbooks that you can use. So I've not dived into the full extent and capability of the AWS playbook. However, you can use the AWS playbook, create your own AWS playbook, and program all the steps that we've taken at the moment, and then go from there. However, again, if you have a whole bunch of, like, if you have a subnet for isolation, I would rather use network ACLs to restrict access to that entire subnet, and then go in and disable all the isolate all the EC2 instances on there as well. Maybe you can also just looking at all the other AWS functions. Maybe you can also use AWS Lambda to actually perform some of the functions that we've performed at the moment, because I think that's that's a very flexible tool that is out there.
All right, cool. Thanks.
Thanks. Thank you very much.
Or maybe I have another question.
Yeah.
So
No worries.
this is yeah, this scenario is specifically, you explained about EC2, but
yeah,
how about let's say a serverless environment, Lambda function is compromised. What can we do?
So in that instance, you would need to check what connectivity that the specific, serverless environment has. So all serverless environments aren't connected the same way, right? Yes, true, it connects to the VPC, and from there you go ahead. So you need to understand where you need to basically, you need to understand where the connectivity is coming from, and from there move on to the isolation for that specific service. So it will be different for different services. So if you take DynamoDB, Lambda, you can take any other service, serverless service. So it'll be different for all these use cases. However, we can follow the same concepts that we've talked. So basically, look at isolating the individual instance. From there, you can look at isolating the network or the subnet. From there, internet connectivity, and so on and so forth. Like technically, even if you take serverless instances, they have an EC2 or some sort of server running. So I think it's the same concept for that as well.
Okay. So sorry. So the playbooks can be used here as well for the serverless stuff as well. Okay.
Correct. Correct. So I've seen a lot of automation or connectivity that can be associated with the Amazon Guard Duty. So I think that's a good option to look at. Guard Duty and Inspector. So they have a bit of integration between the native services. So that's actually a good starting point.
Thanks.
Hi, Lahiru. This is Sean. How you doing, man? That was a great presentation.
Thank you, man.
I had one question, but I think we can cover that in terms of the automation side of things. But I just wanted to say great presentation.
Thank you very much, man. Is there any more questions that we can take? If not, we can jump into the quiz. Okay. So hold on.
So I think we can share the quiz link so everyone can join in, and it will be like a blast round. So just try to answer as many questions as quick as you can, and we'll notify the winner, and you all will be able to get $50 AWS credits for you all.
Okay, hold on. Let me start the quiz and drop the quiz link in the chat. Okay. me drop the link in the chat. Okay. So if everyone could just, head over to the link and register, or you're going to sign in also now, and then we can maybe get started.